That'll be short. Okay, I hear we got to one of the cost problem, a tank with rectangular base. So it's rectangular base, rectangular side, or open top. It is to be constructed. The width is 4 meter. So the volume is 36 cubic meter. If the build of the tank would cost $10 for the base, and $5 for the sides, and what is the cost of this expensive tank? So first of all, what we're trying to optimize is the cost. The cost is what we're trying to optimize, the least expensive, and what are the dimensions? Yes. So the cost is equal to, well, the cost is basically there's four sides, right? Four sides plus one base. And so four sides, and each side is going to cost what the area. So four, if I have rectangular shape like this, four sides. Now we know the width is 4 and volume is equal to 36. There is a height and there is a length. Okay. So there are two sides. Well, there are first of all four sides. So we're gonna add up to change to two side plus two sides. So two side plus two side plus one base. And first of all, the cost of sides are $5. So it'll be no, why two sides? Well, one side is decided to be two times 4h plus, because that's the this side and then the back side. Okay, 4h. And the other two side is going to be this side, which is HL. So it'll be 2 times HL. So HL plus the base is 4L. Now remember, each side costs different price. So each one is the base is gonna be $10. So the base is gonna cost $10 more. And all those cost $5 more. So it's gonna cost $5 more. So that's equal to 2 times 4, it's 8, and 8 times 5 is 40h plus 10HL plus 40L equal to cost. So at first it's not a cost, this is a cost, sorry. Now, with that being said, now let's go decode the secondary equation, which is the volume is equal to 36 cubic feet. So value equal to width times length times height, and 36 is equal to 4 times length times width. And therefore it's going to be 9 equal to LW. If you divide it by both sides by 4. And with that being said, you can evaluate for, wait, sorry, that width is 4, so this could be for LH. For LH. Then 9 is equal to L and a H. Okay, so this is LH. So we got a 40H. Or let me see what I want to solve for. What is the cost of these expensive things? Yeah, I got H, HL, and L. It doesn't matter actually. I'm just gonna do 9 over L is equal to H. So this one will be 40 times H, which is 9 over L, plus 10 9 over L times L plus 40 L. I want everything, I use this to reduce the variables. So I just got 360 over L plus 90. L over L is going to be 1, n plus 40L. Now I'm going to take derivative of the cos. So C prime is equal to 360, and that's going to be L to the negative 1, so there's an L to the 2, negative 2, plus 40, and that's equal to 0, so you've got minus 360 over L squared is equal to negative 40. So L squared is equal to negative 360 over negative 40, which is equal to 9. L is equal to 3. Once you figure out L equal to 3, you can go back to figure out 36 equal to 4 times 3 times H. So H is also equal to 3. So the dimension is going to be 4 times 3 times 3. And that's the case. Now, if you want to find out how much the cost is, well, we just figure out what is the cost of least expensive. So we got to figure out the cost. Then you got to plug it back in. So the cost equation equal to 40 times H, which is 3, plus 10 HL, which is 3 times 3, plus 40 times L, which is 3, so it'll be 120, plus 90, plus 120. So that's equal to 240 plus 90, so it'll be $330. And that is how do I solve the cost equation. At first, I will break down there's a sides, right? There's 4 sides, right? And then I'll break down 2 of the side because I'm gonna take account into this in the back end. So be 4H times 2. So this is represents by 4H, and this represent by HL, and this represent by 4L. Now each one has a different price, so this is actually the cost equation. So the cost equation go in, and then I have this to reduce down my variables, and I'll get the answers, and I'll figure out what is this.